Awesome. Okay. We're live. We're live, everyone. Just gonna close the door. Awesome. So, my friends, we are going to be doing some calculus homework. So, I'm just gonna share. Whoops. Just gonna share my screen. Here we go. What's up, Bear? All right, guys. But before that, we need some stimulation. Hold on. I'm just gonna put this shirt on. Just like, why not? Cool. So we're just gonna play a little bit of Minecraft right now. Okay, cool. So I'm just building like an underground base right now. It's starting to get nighttime. And I kind of like the scenery here. It's pretty nice. Maybe we should get food. I'll just use up my. Come on, bro. There we go. We got some more pork chop right there. Oh, I have a sword. I forgot. Here. There we go. Whoa, what's that? Oh, just like a sun reflection. That's cool. Oh, look, we have another pig and another sheep. Nice. Let's go. We're getting a bunch of food. Look, there's a skeleton. Oh, no, wait. Hold on. There's also a creeper. All right. Hopefully they don't get us. I think we need a crafting table, right? Yeah. And let's make like a chest. Oh, wait, hold on. But you do that in the crafting table. Put it there. Yeah, I'll just get 2 chests. Oh, and I need to make a pickaxe. Here. Let's do this. There you go. Cool. Cool. Oh, wait. Hold on. We have dirt, right? So I'm just gonna replace the wool I have with dirt. There we go. And we can make a bed, right? Oh, we have 2 oak planks. We need 3. Hold on, I'm just gonna. Gotcha. I see. Let's see. So what do we need to do? Let's see. I'm just gonna store stuff in my chest right now. So I'm just gonna put 2 cobblestone right there. You guys put a big chest right here. Yeah, I don't think we need that. Probably don't need that right now. Here, I'll just keep this here. We probably don't need that right now. Keep that stick with me. The oak planks. We can't do anything with the wool, so I'll just keep it there. This can stay here, this can stay here, this can stay here, and this can stay here. Okay, cool. Oh, I also want to make a furnace. So I'm just gonna open up extra space right here. Cool. And here I'll make a furnace. Let's make 2, because why not? Cool. And then, oh, I forgot, we have 1 coal. Can we make a campfire? What does it take to make a campfire? Oh, yeah, no, we don't have that. So I think what I'll do, simply cook our beef. How's that? Got a torch right there. And to check if it's daylight or not, I'm just gonna open up. Here. In fact, I think I can make a use of dirt. Whoops. Very cool. Is it daytime yet? No, it's not daytime. Oh, cool. In fact, I'm just gonna use this up and just create some stone. And let's eat this. Whoops. That's pretty good. Okay. Let's just open up something here. Cool. Now I'm just gonna break all this coal. Beautiful. And I guess I'll just break this copper as well. Oh, that's a lot of copper. It's fine. Let's get our... Hold on. Just to make sure. Yeah, okay. Alright, guess we can begin like a little bit. Minecraft is kind of fun right now. Oh, there's one person watching. What's up? What's up? Okay. 1 stone. Let's put that right here. Is it safe to go outside yet? Well, oh, we need to make... Oh, we can't make... we can't make another pickaxe. We're screwed. Hold on. Let's take that. Let's wait for the next one. Yeah, I don't have any pickaxe. No. Okay. Okay, cool. We can come back out. Well, we need some more wood. Oh, look. Oh, dude, why is my sword? Should I go in the water? Hold on. I got hurt? Why did I get hurt? I thought you wouldn't get hurt. Oh, yo, chill. Uh-oh. What do I do? Oh, I died. Here. I'm just gonna respawn and I'm just gonna get my stuff. Is that everything? And where's the skeleton? Getting some bones would be pretty cool. It looks like he died. Okay, well, Minecraft was fun. However, I think it's time to get done what needs to get done. Let's do some homework. Oh, hey, welcome to the live stream. Thanks for being here. Yeah, I don't think I know you. Are you new here? You're probably new here, right? Yeah. Yo, thanks for being here. But right now, we gotta finish our calculus problems. Oh boy. We're so close, actually, because I have to finish this class by May 1st if I want to continue on other classes. If I don't finish this class by May 1st, then I'm dropped out of all the classes I have after this one. So we're currently in the fundamental theorem of calculus. Then we got a quiz, which should be pretty easy because I think I remember everything well. Then we have 3 practice exams and then the final exam, and we finish. And it's currently April 26th. So, I mean, we could finish by Friday, but I think it would be good to finish around Tuesday because I also need my grade to be in the system. Right now, I think my grade is a 93.63. Hold on. I think that's because I have not finished my homework though. Yeah, right now I have a 45 out of 100 on my assignment because I haven't finished. So after I finish, I should have like a 94.5 or something. That's what I had before. Well, yeah, cool. We're on our last assignment. Awesome. Yeah. Let's do this because there's nothing else better to do on a Sunday morning, is there? Okay, so we're on question 3 because we skipped 3. Given that f of x is in between 1 and 2 and x is in between -1 and 5, use property 8 of section 5.2 Oh, the Stewart Essential Calculus textbook. Yeah, I know. I don't know no textbook right here. Well, we got a video, so that's kind of cool. Estimate the value of this integral. Uh, estimate the value of that integral. Oh, I see. I see. Okay. Compare. Here. Okay. So we have f and g be continuous functions, and our first comparison, whatever, if m is less or equal than f of x, which is less or equal than big M, for a less or equal than x, less or equal than b, then m times b minus a is less or equal than the integral from a to b of f of x dx, less or equal than m. All right, what am I reading? I'm just reading. I'm not understanding. Let's see. Do you guys understand this? So f of x is in between little m and big M. I think I need to go to the bathroom. I'll be right back. Okay. All right. Okay. I see. Is 3 and big M is 5. And A is negative 3 and B is 5. Oh, okay. So just create those. Okay. So we have then 3 times 5 plus 3, 5 times 8, then 40 is less or equal than the integral from negative 3 to 5, which is what we have here, of f of x dx, which is less or equal than, oh, I'm sorry, 3 times 8 is 24. So 24 is less or equal than that integral, which is less or equal than 40. Okay. Good to know. Right. Hmm. Yes, I think we get 24 less or equal than 40, right? Mhm. Yeah. Yeah. Okay, I think I understand the geometric one. Okay. Yeah, I think we understand that. I think we're good with that. But oh, so using this what is this? This property 8, then we'd have let's see. So what was it? M little m times b minus a is less or equal than that integral, which is less or equal than big M times b minus a. So what is b minus a? Minus a is f plus 1, which is 6. And then, so we have 1 times 6, that's 6. So I think here we have 6. And then we have 2 times 6, which is 12. Okay, cool. That's all fun and games. I think I got like an agony right here. It's so annoying right here. Thank you. Yeah, good luck. Thank you. I appreciate it. Cool. Now we're on question 17. All right. Let's do this. In fact, let's do it on a whiteboard. Canva. There we go. Let's get, oh boy. Let's get our pen. And let's do it. So what do we have? In fact, let's split our screen because why not? So, what do we have? We have the integral. Yeah, that's a little ugly. Was it better? From negative pi to pi. Can we make this like a little thinner? So let's just delete this. There we go. So we have from negative pi all the way to pi. Of f of x dx. Cool. So what do we have? All right. I think I'm going a little slow. So we have so that integral, or I'm sorry, f of x is 8x cubed for x bounded by negative pi. Whoops. And pi. And f of x is 9 sine of x for x bounded by 0 and pi. Oh, and this is 0. I see how we're playing this. And in fact, we're like totally getting this wrong. There we go. Cool. So if x is bounded by negative pi and 0, f of x is 8x to the power of 3. And if x is in between 0 and pi, then f of x equals 9 sine of x. So I'm just going to move. I'm just going to put f of x right here to make this clear, to make it consistent. Let's see. Now what do we have? So how do we evaluate this integral? Well, what do you want us to do? Oh, no, that's actually not too hard. We just have to consider 2 cases. I don't think we can draw this, but it's completely fine. So here's what we're going to do. So first, we're going to solve the integral from negative pi to pi of 8x to the power of 3. Oh, no, I see what we're going to do. I see. Okay, guys. Watch this. Hold on. So I think what we do is going to be from negative pi to 0 of 8x cubed plus the integral from 0 to pi of 9 sine of x. So I just want to make sure that we're doing this correctly, and I don't want to waste a lot of time. Let's see. Yes, if c is in between a and b, then we can do integral of a to c plus integral from c to b. That's, yep, exactly what we're doing. We have the correct intuition. So right here, from negative pi to pi, we can split from negative pi to 0, and then from 0 to pi, which is precisely what we did over here. Let's go. Oh, well, kind of, because I think I put ax 3 and 9 sine of x, not rather than f of x. Bro, what's going on, please? Can you stop? There we go. Hold on. So, oh, okay. So you did what I did. Oh, and I forgot the dx. How embarrassing. dx. That's fun. Gotcha. And then we can simply apply the fundamental theorem of calculus. Cool. So what we're going to do, so then, just solve for the antiderivative and whatever. So this is going to be 8 times 1/4 x to the power of 4, evaluated from negative pi to 0. Ooh, but then here we have a signed area because this is negative. Yeah, I'll worry about that later. And then we have plus, what's the antiderivative of 9 sine? Well, we obviously have 9, constant stay. And the antiderivative of sine, negative cosine, negative cosine. What's derivative of negative cosine? Sorry, derivative of cosine is negative sine. Yep, we're good. Times negative cosine of x from 0 to pi. Beautiful. Now what we do, so here we get 2x to the power 4. So here we have, in fact, I'll put a bracket. We have 2 times 0 to the power 4 minus 2 times negative pi to the power 4. Oh, wait, hold on. No, we're doing good. Plus, and then we put another bracket here. We put negative 9 cosine of pi minus negative 9 cosine of 0. What are you doing here, Bear? Oh, what's up with you, bro? Oh, what's up, man? Are you bored? Are you bored, Bear? Oh, buddy. Oh, Bear. I love you, man. I love you, Bear. Bear, do you want to be in the live stream? Hey, Bear. Hey, Batty. I love you, Bear. Wait, dude, why is he trying to take my shot? Oh, he has a ball. Oh, he wants to play. Bear, do you realize that I'm doing math right now, man? You want to play, buddy? You guys look at Bear. Did you guys see Bear right there? Oh, he wants to play. He wants to play, right? Oh, Bear. What a fat dog. All right. Anyways, where were we? So we have negative 9 cosine of pi minus, and then that same term but with 0. So I think we get something like, so 0, 0. So we have 2 pi to the power 4 minus, and cosine of pi, that's negative 1. So that's simply plus 9. Hold on. So we have plus right here, right? Yeah. Plus, wait, and negative 9. So all of this is 9. So plus 9 plus cosine of 0 is 1. So plus 9. So in the end, we have 2 times pi to the power 4 plus 18. And we got that wrong. What happened? How do you do it? Did we get anything wrong here? Gotcha. Yeah. So he did what we did. I think we just got like an algebra error. Here, I'll just do it on paper to make sure I'm getting everything right. So here we have from negative pi all the way to 0 of 8x to the power of 3 plus the integral from 0 to pi of 9 sine of x. Now, antiderivative of 8x to the power of 3 is 8 times 1/4 x to the power of 4. And then here, we're going to use the fundamental theorem of calculus in order to evaluate. Hold on. But since this is negative, yeah, no, that's good, right? Yeah. We're doing good. Plus and negative 9 cosine of x from 0 to pi. Right? We're not doing anything wrong. So this is 2. This is 2. 2x. 2x to the power 4. So we have 2 times 0 to the power 4 minus. Oh, I see what we got wrong. 2 times negative pi to the power 4. Oh. Then plus. Oh, and should it be in brackets? Oh, a bear wants to play. He wants to play, doesn't he? You're a good boy, Bear. You want to say hi to the camera? You want to say hi to the camera? Right here. Hey guys, say hi to Bear. He loves to play with the ball, and he loves to eat. Those are the only two things that he likes to do, and he likes to move around. Bear, move, chill. Gosh. All right, I think. All right, Bear, buddy. Oh, Bear. Hey, do you guys have dogs? Yeah, because dogs are a lot of work. 5 people watching right now. Welcome. We got 6. What in the world is going on? Thanks, guys, for watching. Well, thanks for joining, guys. Now we totally got to get this question correct. So hold on. So now we got finished writing our bracket, and then plus, and then we have negative 9. Hold on, we just got to put a bracket right there. Negative 9 cosine of pi minus negative 9 cosine of 0. Close brackets. So 0 to the power of 4 is 0. 2 times 0 is 0. So we only get here. Hold on. Dude, Bear, what are you get out of here, bro? Hold on. So negative pi to the power of 4 is wait, what's negative pi to the power of 4? Oh, okay, no. I don't think that matters anyway. Okay, hold on. But whatever to the power 4 is going to be positive. So that might as well just be pi to the power 4. So here we have negative 2 pi to the power 4 plus cosine of pi. That's going to be cosine of pi is negative 1. No, why did I just close that, dude? What am I doing? Let's go to history. Yes, you guys can look at my search history. Got nothing to hide. Anyways. Oh no, you just got to sign in. Hold on. So what is cosine of pi? Cosine of pi is negative 1. Let's go. Dude, okay, hold on. Infinity. Why are we complicating this so much? Hey, What is up, guys? Hold on. Where are we? Right here. So, where were we? Cosine of pi is -1. So we have -9 times -1 minus, open parentheses, -9 times 1, because cosine of 0 is 1, right? Yeah. So -2 pi to the power 4 plus, now let's simplify it inside of the parentheses, -9 times -1 is 9, and -9 times 1 is -9, and -9 is going to be 9. Gosh. Oh, so I think we were super close, but we just forgot this negative right here. Oh, well, would you look at that? Would you look at that, guys? Oh, that's kind of cool, isn't it? Here, let's also put some emojis. That's kind of cool. Hold on, let's put some glasses as well. No, I was kidding. Cool. All right, well, we got to continue. Here, I'm just going to close my door. Cool. So in problem 18, we are halfway there. Oh, and Bear just got in. Let's do this. Here, what if we take another break with Minecraft? Because Minecraft was kind of fun. No, I was kidding. We only go 36 minutes. I don't think it's even that bad anymore. After like an hour and a half, I guess we can talk. But no, 36 minutes of doing math like this, I don't think we deserve a break yet. Use part What's part 1? There are 2 parts. Hold on, let's search up in Wikipedia. There's a fundamental law of economics. That's kind of cool. I wonder what that is here. But then, hold on. Fundamental theorem of calculus. And what's this? Fundamental laws of economics are core principles that describe how individuals, businesses, and governments make decisions under scarcity, guided production, and consumption. Wow. What did I just say? Sorry, I was reading about Muhammad. So, I mean, tough stuff right there. And resource allocations. You guys heard that, right? That was kind of crazy. Yeah. Core principles, law of demand. Okay, why am I reading about economics? We're reading calculus right now. Hold on. There it is. So that links concepts of differentiation and integration. Gotcha. The first part of the theorem, and I think that's part 1, states that for a continuous function f, an antiderivative or indefinite integral f, can be obtained as the interval of f over an interval. As the interval of f over an interval with a variable upper bound. Gotcha. Don't know what that means, but okay. Conversely, second part of the theorem states that the integral of a function f over a fixed interval is equal to the change of any antiderivative f between the ends. I mean, I should know what that means, but I'm sorry. Oh, look, it's mean value theorem. I remember doing that one. Oh, that was cool. Oh, Bear. Hold on. Velocity. Interesting. Okay. I mean, I don't know what I'm reading, but it looks pretty interesting. Oh, here. Wait. Proof of first part. Hold on. So first part. Let f be a continuous real-valued function defined on the closed interval AB. Bear, you are the fattest dog I've ever met. But I love my dog. Let f be the function defined for all x in AB by big f of x equals the integral from a to x of f of t dt. Gotcha. Well, that's all fun and games, but I think that we can just do with what we already know. I love you, Bear. I love you, buddy. Let's see. So now Let's just write down what we're doing. We have f of x equals the integral from 2 to x. Oh, interesting. Oh, look what we have here. 1 plus t squared dt. And we need to determine f prime of x. Interesting. What I found interesting is that here our input variable is x, but then here we have t. Well, what I do see here is that 1 over 1 plus t squared is the derivative of, I think, arctangent. Yeah, but no, I don't know what to do here. Let's just go to practice. Okay, I'm confused. What are we supposed to do here? Should I ask Copilot? Microsoft Copilot, your AI companion. Just put some think deeper. How would you solve this? What are you supposed to do? I mean, I'm curious. I'm curious what you're supposed to do. Okay, so answer. By the fundamental theorem of calculus part 1, if big f of x equals the integral from a to x of g of t dt, then f prime of x equals g. All right, well, I mean, like it said, they're inverses, right? Here, g of t equals 1 over 1 plus t to the power of 3. Dude, why does dog just come? Okay, we're good now. So let's see. Uh, okay, all right, it's okay. So believe we get 1 over 1 plus x squared since we must replace. Okay. So if f is continuous on AB, here, let's sketch the graph. In fact, I'm just going to move this over here. That's continuous, right? Yeah. So, so is it just going to be, hold on, I don't think I understand this concept quite well. I'll probably have to review it. Oh, no, cancel. That's also right. Okay. All right. See the process of how they did it. No, you're not going to show. What does the video show? Okay. X, yeah. Yeah. Don't be variable. Okay. I see. Okay. Okay. I see. I see. Okay. Let's continue. Well, it's glitching a little bit. Hold on. How can I? Okay. Let's continue. So we have f of x equals the integral from x to 12 of t to the power of 6 dt, and I need to determine f prime of x. So is this I'm sorry. What am I supposed to find? Whether f of x is continuous or the integral is continuous? F. Well, yeah, obviously, right. I don't know if an integral can be continuous. Yeah, so if f is continuous on AB, yeah, it looks continuous on AB, right? And you define big f of x. Well, here we did a little f of x. Um, gotcha. Okay. Well, that's gonna be x to the power of 6, right? Phew. Okay, because I honestly was just doing this robotically, so I don't quite understand what I'm doing. Hold on. So f of x equals the negative integral. And why is that? Oh, because x should be on top? Okay. Well, I see. Yeah. So if you want to switch the the limits of the, oh, I'm sorry, what is that called? Integrating. Okay, whatever. I don't know. Yeah, just negative the integral from 12 to x of t to the power of x dt. Okay, I see. So this will be negative then. Oh boy. Okay. Well, we got to review that because I can't be like this on a quiz. How many first parts of fundamental theorem of calculuses are we going to do? All right, this is 2 minutes. It shouldn't be too hard then. All right, so I think what she's going to say is that we need to make the entire thing negative so we can have x as the top bound of the integral, and then we can have 5 to x, and then I think it's going to be negative sine of x to the power of 5. Is that what you're going to say? Hold on. Yeah. Flip it, yeah. Okay. Yeah. Mm-hmm. Oh boy. Okay. I think I understand. So here we just need a flip to get 1 to x. Whoops. And we get negative, whoops, sine of x to the power of 4, I think. Okay. Okay. But yeah, it looks like it only works for it does not work for complicated functions. So if I had something like sine of x, or I'm sorry, like sine of x to the power of something, or x plus a something, like we have to apply the chain rule. I don't think that works in these cases. Yes, all right. We are not using the first part. Um, you can do it with x on the bottom also. Okay. If an integral goes from a of x as lower bound to b of x as upper bound, the answer is b prime of x times f of x minus a prime of x f of x. Okay. Gotcha. Okay. I guess so. They're probably just teaching us uh to make this a little more straightforward by putting x at the top. Probably. Hmm. I'm not sure. I guess I'll have to look into that. Well, thank you for a comment. Thank you. Let's see. Hold on. We have 4, 9, 11 problems to finish. Let's do this. So we have y equals the integral from -6 to square root of x of cosine of t over t to the power of 6 dt. Okay, so dy dt equals, ooh, but now here we have like a composition of functions at the top. Is there a way to apply the first part? Hold on. Yeah, to use the chain rule. Uh-huh. I see. Okay, okay, hold on. Let's follow carefully what they do. So dy dx. Oh, okay, I think I put dt. No, it's not dt, it's dx. That's what we want to do. Dy dx equals d dx of the integral. Okay, hold on. What's the integral you're given? You're given from -6 to square root of x. And here we're doing from 0 to u. Gotcha. I see. Okay. Oh, let's do it. So from 0 to u of cosine of t over t to the power of 6 du. Interesting, du. And this equals d du of, hold on, gotta make this neater. D du of the integral from 0 to u cosine of t over t to, okay, all right, that's it. I'm sorry, I don't know what I'm doing. I'll probably have to watch a video or something, but I think I'm not understanding at all what I'm doing. And to be honest, I only watched this first part of the video. I don't think I've watched part 2, 3, or 4. Here, let's see if there are other problems that we can do. Oh boy. Okay. So b prime of x becomes 0. 0 people watching right now. Oh, one person watching. Cool. Huh. Let's think. What should we do? Well, I gotta finish this homework, hopefully within the stream, but we gotta, I mean, I gotta understand. Hold on. Let's see. So, oh, I see. Why is it glitching? Hold on. If I put task manager, let's. All right. Well, I'm just gonna close all. In fact, I'll just close this. Why is this glitching? Oh, I see. Okay. So is t gonna be t of x? Oh no, but we have dt. From x to 5. Yeah. Okay. Oh, okay. I see what they're doing. Right. Yeah. Mhm. Right, yeah. Do we have to apply the square root? Right, mhm. Hold on. Oh, wait. Interesting. So the antiderivative hold on. Yeah, the antiderivative of x squared or okay, fine. How about this? The derivative of or are you sure it's 1? I mean, I thought it was gonna be 1 over 2x. Um, hmm. I'm just gonna put it back. Yeah, because, that's an antiderivative. So, uh, I'm confused. Okay, this is glitching. So the oh my boy. Okay, hold on. So if I have x, okay, let's imagine just any function x. Um, hold on. But how does that work? Oh no. Sorry. T. Oh, there you go. T. So if I have t squared, well, let's imagine that. So then the antiderivative of that would be t cubed over 3. And then evaluated at x squared, that's going to be um, t to the power of 6 over 3, I think. And then the derivative of t to the power of 3. Oh, sorry, t to the power of 6 over 3. I see. Yeah, so it's going to be f of a normal f. Yeah, it's going to be, hold on. The derivative of t to the power of 6 over 3 is going to be, or t x, oh my boy. Gosh, dude, bro. What if I just ask Copilot? Right, uh-huh. Yeah, because f of u, a big F of u is going to be an antiderivative. Uh-huh. Right, okay. Okay. Okay, hold on. So we have big F of u equals the integral from a to u of f of t dt. That variable change is important. So we have big F prime of u equals f of u. So f of u is simply going to be the first part when you apply the fundamental theorem of calculus. F of u, and then that's going to be f prime of the antiderivative. Yeah, the antiderivative is the antiderivative's derivative is back to where it was. Your actual function is g of x equals big F of x squared. Right, uh-huh, yeah. And then you differentiate that, you get, well, f prime of that times f prime of this, the derivative of the outer function times the derivative of the inner function. I see. Okay. Mm, g of x. Okay. Oh, I see. Okay. Okay. I think this is much easier than what we're complicating it to be. If I have the integral from a to g of x of f of t dt, then if I apply the fundamental theorem of calculus, we have the antiderivative of of little f of t, which is big F of t, evaluated from a sorry, g of x minus a. So it's going to be big F of g of x minus big F of a. I see. Okay, so big F of a is going to be constant. So that's sorry, no. What does that mean? Big F of a. So we know that a is going to be the derivative, the antiderivative of a constant, and that's oh, and then you do the derivative of all of that. You get f prime of g of x times g prime of x minus the derivative of the antiderivative of a. So here we get little f of g of times g prime of x minus a because big F prime of a is going to be or that's going to be f of a little f of a. I see. So what happens here? I'm just gonna go back for a second. Yes. Right. Yeah. Hold on. So big F of A is an antiderivative. What do you mean that's constant? Okay, fine. I see. Okay, here. So let's apply what we just learned to this problem. So we have y equals the integral from -6 to square root of x of cosine of t over t to the power of 6 dt. So dy dx equals d dx of, and then we're gonna find the antiderivative. Okay, let's see. So how do we do this? So we can't apply the quotient rule. We don't know how to do that. Let's split this into two functions. So we get sine of t times, sorry, not times, plus, or times actually. Hold on, I'm just gonna simplify this. Perfect. So times, and then here we have Oh, and this is t to the power of negative 6. So here we have 1 over negative 5 t to the power of negative 5. Oh, and this is going to be, and then, hold on. So from negative 6 all the way to square root of 6, okay? And then we have, yeah, so dx of all of that, and this is going to be sine of square root of x times negative 1/5 of square root of x to the power of negative 5. Hold on, I'm going to do that. Minus sine of negative 6 times negative 1/5, negative 6 to the power of negative 5. Close brackets. So then we have d dx of sine of x to the power of 1/2. Just simplifying. Hold on. So what are we trying to do? We're just trying to calculate the first derivative. Oh, okay. No. I think we're complicating things. The derivative of a square root is 1/2. Wait, hold on. Do you apply the chain rule to a square root? If I have, all right, the derivative of a square root, that's 1/2 x to the power of negative 1/2. No chain rule involved, right? Hold on. So without doing all of that, what if I just do 1/2 times cosine of x over x to the power of 6 times, sorry, to the power of a negative 1/2. All right, so then, oh, okay, so I think I'm stupid. I kind of forgot when to apply the chain rule. You don't apply the chain rule when you have x, and you always apply the chain rule when you have something else, I think. And then we do the derivative of that of the inner function then. I guess so. So how does that look like? So we have cosine of x times negative sine of x minus okay, hold on. No, that's wrong. 6x to the power 5 minus negative sine of x. And in fact, I'll just times t or x to the power of 6. Cool. Over t to the power of 6, all of that to the power of 2. Is that it? No, whoops. No. Okay. This is getting tough. Okay, dude. Let's see how you solve this. Bro. Oh, I see. Wow, dude. Why is it glitching so much? I have 4 tabs open. I have nothing else open. Okay, this is so funny. I don't know what is going on. I don't know why this is so slow. Oh, is it because of the internet? What do you mean no enter? There we go. Oh, that's so much better. Yeah. Okay. Right. Mhm. I see, I see. Okay. So applying this logic, um, we should get we should get hold on, cosine of x over x to the power of 6 times 1 half x, bro, no, x to the power of negative 1 half, I think. Yeah, well, I mean, I think that's correct. That's incorrect. Interesting. Um, hold on. Oh, sorry. I'm so dumb. There we go. Because we're evaluating f of x at square root of x. There we go. That is beautiful. We are back in the game. Let's go. We got that. We did it, guys. Good job. We are. All right. I am having trouble understanding this. My score is 67, but my completion is 69. Why? What did I get wrong? All of these I got correct. All right. Find the derivative of f of x, where, okay, cool. So, so you want to play like that, eh? So I think we get sine of x over 1 plus x squared. Hold on. Okay, pause, pause, pause. What am I doing? So I want to evaluate this at 1 minus 4x. Even though this oddly looks like, okay, 1 minus 4x, 1 minus 4x times negative 4, I think. Cool. So what did we do here? So all we did is negate the entire thing so that we could switch the lower and the upper bounds to get the integral from 4 to 1 minus 4x. And then after that, we apply to the fundamental theorem of calculus where we did sine of 1 minus 4x over 1 plus 1 minus 4x squared minus sine of 4 over 1 plus 4 squared. So we derivate the entire thing, and we get this first term right here. We literally get the exact same thing per the definition, and then times a bunch of constants, so that's 0, and then we do times the derivative of the upper bound because we had big F of 1 minus 4x. We got this first term by doing the derivative of the outer function, and then we had to do the derivative of the inner function. Makes complete sense. Oh wow, this is so hot. Let's go. So find the derivative. Literally the same thing. Oh, but we have x on both the upper and the inner bound. That's insane. So how does that go? How does that go, friends? Is it time for Minecraft? No, I don't think so. I think we still have energy left. Hmm. Hmm. Mhm. Yes. Yes, ma'am. Beautiful. Makes total sense. Cost. Mhm. Mhm. Okay. Gotcha. A negative, right? Right. Oh, gotcha. That's beautiful. Mhm. Hold on, wait. Sorry, what do you do? Hold on. Uh, did you do the anti Oh, no, no, no. Right. Mhm. You just did negative cosine evaluated at 2x times the derivative of 2x. Excuse me. And then we do plus cosine of x cubed times 3x squared. Mhm. Gotcha. And that's actually beautiful. I think I completely understand now. So, what we will wait, and what is part 4? Okay. Probably applications now. Cool. So, well, I love this because I think we are understanding completely what to do. So, how to do this? So we have big f of x equals the integral from x to the fifth to x to the fourth of 2t minus 1 to the power of 3 dt. So the way to do this, f of x equals the integral from x to the power of 5 all the way to a of 2t minus 1 to the power of 3 dt plus the integral from a all the way to x to the power of 4. Hold on. Um, should we negate the entire thing first? It's fine. Cool. Um, so f of x or big F prime of x, is going to be d dx of in brackets this flipped, so a all the way to x to the power of 5 negative 2 minus 1 to the power of 3 dt plus the integral from a to x to the power of 4 of 2t minus 1 to the power of 3 dt. Beautiful. Let's see. Now, what we do is fairly simple. We have d dx of negative, and then here we apply our FTC. So, what we do is, what's, oh, no, no, no. No, actually, no. No need to do that. What you get is 2 times x to the power of 5 minus 1, all of that to the power of 3 times 5x to the power of 4. And then, um, hold on. Yeah, and a is a constant, right? So no need to worry about that. Plus, and then here we have 2 times x to the power of 4 minus 1 to the power of 3 times 4x to the power of 3. You close the brackets, and then we have d dx of yeah, okay, that's simplifying and stuff. You get 2x to the power of 5 minus 1, all that to the power of 3 times 5x to the power of 4 plus 2x to the power of 4 minus 1 to the power of 3, 4x to the power of 3. Well, alrighty. I mean, cool. Let's see. So, bro, so we get, okay, why is this like in the way? Oh, I'm sorry, but we're supposed to find the derivative, right? Here, no, I can't open another tab because then my computer will crash. No idea why. In fact, I can't do it there either. It's fine. Gotcha. So, doing the derivative of all of that mess, we do 3 times 2x to the power of 5 minus 1 squared time all of that squared times the derivative of the inner function, which is going to be 10x to the power of 4. And this is times 5x to the power of 4 plus the derivative of 2x to the power of 4 minus 1 all the raised to the power of 3. Wow, nobody's understanding what I'm saying. Here, squared times 8x to the power of 3 times 4x to the power of 3. So here we get, yes, beautiful, yes, times 50x to the power of 8, I think. Hold on. Yeah, you added the exponents. Plus 6. All right, well, this should be correct. Okay. I have a feeling I got something wrong. Nope, let's continue. Irrational fears. Yep, this is probably going to get wrong. I have a feeling. Yes. But it's okay. It's completely fine because we're learning. I want to see how my answer should be. Oh, dude, this is so slow. Woo, that's a lot. Wow, this looks quite close. Hold on, I might actually be very close. Where is that negative sign? Yeah, we completely missed it. What are we doing? Yeah, we gotta negate all of that. That's good. Okay, I think that's good. There might be something wrong, yeah, I guess. Okay, hold on. Hey, what's up? Welcome to the live stream. I'm from Pakistan. Cool. It's currently April. Is it hot there? Is it hot in Pakistan? Probably. It's probably around like a hot part there. Yeah. Yeah, well, thanks for being here. It's good to have you here. Kind of. Okay. Do you like math, or are you just watching this for fun? Okay. All right. Well, thanks for being here. Yeah. Here, we still have some problems to complete, but we're getting there. We're almost done. I'm just trying to decide uh, what he got wrong here. Let's see here. I guess I'll do it all over again. Hold on. I just popped up. Oh, cool. Oh, really? Okay. Are you a high schooler? Are you a college student? For a math exam. Okay, well, good luck. Good luck with whatever you have going on. What math are you preparing for? A level? Oh yeah, they're probably different terms for high school and a college and hold on. Uh, levels. Hold on. Oh, gotcha. Okay. Algebra, calculus, trigonometry, statistics, mechanics. Wow. That's impressive. Here, so okay. You see all of that. Wow. Okay. Oh, so you also see physics as well? Okay. Statistics. Whew, that's so cool. Combinatorics. Wow. Okay. That's quite impressive, man. Cambridge. It's a little difficult. I mean, yeah, it looks pretty difficult. You're covering a bunch of math. Yeah, like continuous math and then discrete math. Yeah, well, good for you. Where am I from? Well, I'm from the United States. Yeah. Yeah, I don't think we see all that math together. I mean, actually, like, I don't even think you see like a combinatorics in school. You probably see that like in college. Okay, gotcha. Do you mean like Cambridge? Are you in Cambridge right now, or is this like to do like with like a chemistry? Oh, a good question. I'm not sure. I just don't think I've ever heard of it. Yeah, other bunch of stuff I don't know here. So if I don't know something that American kids I don't know, I guess that's not cool. But it's it's just what it is. Yeah. Um. Yeah. Yeah. But there are a lot of things that I don't know. Okay. Hold on. I want to see if. Oh, okay, that's fine. Oh, and there's O level. Okay. A. Gotcha. Yeah. No, I don't think I've heard of this. There's like a. Okay. Gotcha. Okay. Wait. So. Oh. Wait. So O level is after. It is foundation strategy. Okay. I see. Yeah, well, I guess I gotta be more informed then. Which board am I in? Let's see. I'm not sure how to answer that because I'm homeschooled, so I don't know if all of those school terms apply to me. This class that I'm taking right now is an Arizona State University, so it's at a college. I don't know what board that counts. Yeah. Why am I doing homeschool? Um. Well, I think I learned better. Uh, I don't think I learned pretty efficiently. Uh, Sitting in a classroom for some hours. Yeah. Oh yeah, man. You gotta tell me more about how your exam goes in the future. Please pop in another live stream. Yeah. Tell me how it goes. All right. But meanwhile, we just gotta finish this problem. I don't know why it's taking so long. But I have a question because it looks like the upper bound is less than the lower bound. So can we split it the same way? Here, I'm just gonna ask Copilot. Hello? What's going on? There we go. How would you split the function to have oh fine. Split the integral into two, each with one function as a bound. Yeah, man, see you. Good eye. Let's go. Let's see. Cool. So we did it well, right? Yeah. So what we got to do is now f of x equals the integral from x to the power of 5 to a of 2t minus 1 to the power of 3 dt plus the integral from a to x to the power of 4 of 2t minus 1 to the power of 3 dt. Gotcha. All right. And because we want to have our functions as upper bounds, not lower bounds, well, wait, hold on. Wait, why is that? Oh, dude, hold on. Because it'll be negative or why? Hold on. Oh, why is it so slow? Bro. Hold on, dude. I'm just gonna go to the bathroom. There we go. Why do we want to do that though? Bro, what's going on? Bro. Okay, hold on. Dude. Hold on. I do think. Hmm. Oh, yeah, I think. Okay, I see what we got wrong. Okay, so yeah, so we just get that. We only had x. Whoops. What? Dude, this is to the power of 4. Still? Oh, wait, whoops. Hold on. This is actually to the power of 5. There we go. Now, this should be correct. Oh, boy. Oh, whoops. No, 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 no. Wrong one. That should be correct, actually. There we go. There we go. Yo, what's up? I look stressed. I look stressed. I don't think I'm stressed, but I'm focusing to understand this concept, which is a little tough. Nice bed. It's cool. It's pretty comfy. Thanks, man. All right, we got 6, 7, 8. Hold on. Wait, 5 + 3, 8. We have 8 questions left. Oh, come on, guys. We got this. We got to finish this. Gotcha. So, here's what's up. Find the derivative of that. So, we do g prime of x equals. Hold on. Yes. d dx of this. Oh, okay. So we split it. That's beautiful. And we get whoops, hold on. All right. We're just so good. Wow, let's go. We have been streaming for over 2 hours. Come on. We got this. Come on. We got this. We got this. We got to do this. So we have let's go. What's up, guys? Thanks for sticking with me in this live stream. Yeah, we just have 6 questions left. We have 20% left. We've got to finish this. We've been doing a lot of integration, like all of this. It's a bunch. But we're doing good. We're doing good. Oh, my pencil broke. My nails, dude. I need to wash my hands. Yeah. Let's see. So now, gotta find the first derivative. We do that. Oh, okay. Oh, this is easy. Yeah, so it's just that. And the second derivative is going to be yeah, okay. Ooh, okay. I don't think we've seen this yet. Find the average value of the function. Then we have another average value. Find the average value. And then we have velocity. Okay, so these last questions, they are gonna be different. Oh boy. Okay. We go 2 hours and 20 minutes. Incredible. Incredible. Is it time to play Minecraft a little bit more? Well, no. I mean, 5 questions is a lot still. All right, I'm just gonna watch this video. Let's see how they do it. Oh, awesome! It's only 3 minutes. Well, hold on. I think this includes the mean value theorem. Probably. Hold on. So, find the average value of the function f of x squared on the interval 1 to 4. Okay, it looks straightforward. Mm-hmm. Hmm. Mm-hmm. 2/3 x to the power of 5 halves. Or sorry, 2/5 x. Oh no, sorry, 3. You're right. Mhm. Yeah. Oh, okay. Is it just that straightforward? Mm-hmm. Mm-hmm. Cool. I see. Okay, it's not too hard. Let's do it. So we have f of x equals x squared. So the average value is going to be 1 over 4 minus 1 times the integral from 1 to 4 of x squared dx. I think, right? That's perfect, yeah. So we have 1/3 times 1/3 times x to the power of 3 from 1 to 4. And that's going to be 1/3 times, and then it's going to be 4 to the power of 3 over 3 minus 1 over 3. This is going to, in 4 to the power of 3 is going to be 4 times 4, okay, 64, right? 64 over 3 minus 1 over 3. So 1/3 times 63 over 3. And this is going to be 63 over 9. Beautiful. And we got to find the average value of f of x equals 7 sine of x plus 5 cosine of x. Okay, so we do this by 1 over 7/3 pi minus 0 times the integral from 0 all the way to 7/3 pi of 7 sine of x plus 5 cosine of x. Okay, so this equals to 1 over, or in fact, this equals to 3 over 7 pi times the integral from 0 to 7 pi over 3. Oh no, we don't have to rewrite that. Just apply the theorem. So times it's going to derivative 7 negative cosine of x plus 5 sine of x from 0 all the way to 7 pi over 3. This equals to 3 over 7 pi times 5 sine of x minus 7 cosine of x from 0 to 7 pi over 3. And this equals to, okay, over here, equals to 3 over 7 pi times oops, there we go. So we get 5 sine of, okay, here. Minus 7 cosine of this. Oh, great. There you go. Okay, so let's put another set of parentheses. Minus 5 sine of that minus 7 cosine of that. All right, so we got many errors here. Not cool. First of all, the 7 pi over 3, dude. Okay, that's our answer. Oh, cool. We could have simplified. It would have been good if we did so, but right now we just gotta understand the concept. 3 problems left. Come on, guys. We're doing good. Hey, what's up? Chuck, right? Chuck, yeah. Hey, yeah, man, what's up? Yo. All right, come on. Let's finish this. So, we have f of x equals 25 minus x squared. Cool. So, we have 1 over 2 minus 0 times the integral from 0 to 2 of 25 minus x squared. Yeah, so we have 1/2 times 25x minus 1/3 x to the power of 3 from 0 to 2. That's 1/2. All right, so and then find a c. That's equal to the average value. Okay, so let's simplify this. So this is 0, 0, 0, 0. So we get this. Hold on, I didn't want to see if this is correct. Okay, cool. This is equal to 50. This is equal to 8. This is 150 over 3. Therefore, 142 over 3. Cool. Finally, that multiplication, we get 6. 142 over 6. And using Desmos, (142 over 6). Okay, well, that's obviously not a nice number. I don't see if that's correct. That's still correct. Perfect. So, f of c. Okay. Well, let's see. Oh, okay. No. Much easier than we think. So 25 minus x squared equals to 142 over 6. X squared equals to, okay, bro. Negative x squared equals to 142 over 6 minus 25. X squared equals to 142 over, or negative 142 over 6 plus 25. Oh, why didn't that work? Oh, whoops. There you go. Cool. 2 problems left. So we have like a velocity problem, and then we have, okay, these look tough. Oh, we only have 2 problems left. Come on, bro. Ugh. I mean, right now I'm really not thinking. I'm just plugging and chugging right now. I know it's not cool, but I mean, hey, what can you do? Well, actually, this problem should not be that hard. I'm proud of myself. I did all of this in just a single day. Well, I did some of these yesterday. Okay, well, Oh wait, what? Find the car's average velocity. Oh, I could have done this all along, bro. Okay, hold on. So we have 1/5 minus 1. Yeah, because t is an x value. So then we have times the integral from what, 1 to 5. Oh, right, sorry. What am I doing? You have to find a car's average velocity. Oh, so I need to. Well, I mean, what? Why don't I just find the double derivative, right? Hold on. Oh no, we're good. Gotcha. So we have 1/4 times 3/2. So 2/3 t to the power of 3/2 plus 5x. They're gonna be from 1 to 5. Okay, perfect. So we have 1/4. Okay, perfect. So that's gonna be 2/3 times 5 to the power of 3/2 plus 5. Oh no, hold on. Plus 5. 5. Okay. And then we have 2/3. Bro, what happened? Times 1 to the power of 3/2 plus 5 times 1. Is that the answer you want? Alright, beautiful. Oh, I remember this. This was cool. When did I see this though? Hold on. Gosh, dude, I look so smart with. I was kidding. I was kidding. Hold on. Where's displacement? Dude, what am I writing? I have no idea. Okay, hold on. So displacement for a moving object is given by the integral of velocity function over integral of time. Thanks for letting me know. Here, I'll just write that down here. Notepad. Why is it so slow? Dude, oh, there it is. Beautiful. Dude, I literally have one question left. I mean, save. Cool. So is given by the end. Beautiful, and then Yeah, see how you got that? Hold on. That is 5 times 1, minus 5 times 1/2 t squared. Okay, so I think minus 5 times 1/2 t squared. Nice. And why? Oh, I'm so stupid. Beautiful. So for us, we have 25 times 5, which that's 125. So we have 125 over 2 plus 30 minus, and then we have negative 1. Okay, hold on. We got that right? Yeah. Negative 1 to the power of 3 is going to be negative 3. So here we have negative 3 over 3. Then we have negative 1 to the power of 2. That's 1. So we have minus 5 halves. And then we have minus 6. Simplifying, we get, hold on. What is 125 over 3? No, you can't do that. And then we have plus 1, plus 5 halves, plus 6. Beautiful. Simplifying even further, plus 37 plus 5 halves. Simplifying even further, you get 125 over 3 minus, okay, hold on. Think. Yes, 120 over 2. Ooh, there we go. That's so hot now. Let's go. So we get 125 over 3 minus 60 plus 37. Then we have 125 over 3 plus, you get minus 23. 23 times 3 is going to be 23, 46, 46, 49, 69. So we have 125 over 3 minus 69 over 3. And ultimately here we get, hold on, so 125 minus 69, 125 minus 70, 55, 56, 56 over 3, 56 over 3. 56 over 3 is what? Yeah, no, you can't do that. So 56 over 3. So that's our displacement, right? Displacement, that's for real. So we're minute 248. Gotcha. So we have 56 over 3. Beautiful. That's, oh my gosh. Imagine if I closed that. That's wrong? What? How is that wrong? Let's go to Desmos then. Okay. No, cool. We're learning. Get out of here, bro. So we have the integral. Oh, awesome. It does that. So from negative 1 to 5 of x squared minus 5x plus 6 dx. So I have 125 over 3 minus 125 over 2 plus 30 plus 1 plus 5 halves plus 6. Okay, so we already got something wrong here. Algebra, am I right? Make sure to pay attention to algebra, kids. So we have 1/3 times 5 to the power of 3 minus 5 halves times 5 to the power of 2 plus 6 times 5 close parentheses, minus 1/3 times -1, 2. Stop. -1 to the power of 3 minus 5/2 times -1 to the power of 2 plus 6 times -1. Perfect. So we have that correct. So let's see what we did wrong now. So here, 5 to the power of 3 is 125. So this is good. 5/2. So 5 squared is 25. 25 times 5, well, that's 125, right? Yeah. All right. So let's just put some parentheses over here. Let's put our dandy old minus sign. And then here we're going to have -1. Oh, yep, I see what we got wrong. Incredibly stupid. Not cool. There we go. Oh my gosh. Why would we get that wrong? Not cool. Not cool at all. So we have plus 1/3. Gotcha. So we have plus, plus, plus. Perfect. 18. Now, okay, well, yeah, 18. Right. So that's wrong. That's right. What? So what is going on? Our displacement is clearly okay. All right. Well, let's watch the video then. I mean, it's 28 minutes long, so we're I mean, clearly we didn't do everything that we needed to do. But I think, yeah, bro, I think I'm a minute 248. Huh? In 4 minutos, okay. I'm on the last question. I just gotta finish it, right? Dude, why is the quality in this video so bad? Oh, wait, so we were right. Our interval is correct. Oh, no, no, no. I think what we got was correct. However, and now the distance traveled. Hold on. Wait, I just want to see how he does this one. Hmm. Yeah. Okay. Oh. Mm. And here we get so that adds to -5 and that multiplies to 6. So how about 1 and negative no no -1 and bro, adds. How about -1 and -6? No. -1 and -4. Bro, why does this factoring have to be so hard? It was always so hard. And they never tell us. Why is the computer so slow? Can we go a little quicker? Dude. Huh, good to know. Gosh. Yeah. Mhm. Mhm. So just let's test um, when the function is positive and negative, easy. So test, I don't know, 1. 1 means 5 plus 6. This is gonna be dude, what is 1 minus 5? Negative 4 plus 6 is 2. So here it is gonna be greater than 0. Right. Then here we test, um, it's 2.5. 2.5. Dude, buddy. So, uh, 2.5 squared minus 5 times 2.5 plus 6. That's gonna be okay, we did that right, right? Perfect. So this is gonna be v of t is less than 0, and then when we have 4, this is gonna be v of t is greater than 0. Gotcha. So I completely see what is going on right now. So we're gonna have, a positive velocity increasing and decreasing, then increasing again. Mhm. Mm. Yes, ma'am. Um, that's negative, So he got exactly opposite what I got. Yeah, well, sine area. Just v of t. Well, negate that. Right. Yes, sir. Mhm. Right. That sounds good. Mhm. Sorry, I just gotta wash my hands. My nails are so dirty. I like it. So we're just going to pause there, and I'm just going to evaluate this in Desmos. So we have, here we go, 1/3 times -1 squared. What? No, cubed. Minus 5/2 times, okay, not -1. We started off wrong. We currently have 5 or 2. 2. That's what we have. Dude, stop! Oh my gosh, so annoying. 2. 2 plus 6 times 2. We did that right? We can't have any algebraic errors right now. We can't. I swear. I'm going to crack. And we have 1/3 times -1 minus 5/2 -1 squared. And I know we forgot that to the power of 3. Plus 6 times -1. All right. We have this. We have 13.5. Now, to evaluate the second integral, we have -1/3 times 3 to the power of 3 plus 5/2 times 3 to the power of 2 minus 6 3 minus -1/3 times 2 to the power of 3 plus 5/2 times 2 to the power of 2 minus 6 times 2. Beautiful. Now, for the final integral, we have 1/3 times 5 to the power of 3 minus 5/2 times 5 to the power of 2 plus 6 times 5 minus all of that 1/3 times 3 to the power of 3 minus 5/2 times 3 to the power of 2 plus 6 times 3. All of that. So, taking into consideration negatives, bro, don't do that, please. So it looks like we get this ugly number. We did it. We did it. Oh boy. Okay, so I'm just going to close Desmos now. Okay, I'll probably take a screenshot because I'm kind of proud of this work. Let's go. Guys, want to know how cool this is? So we finished all our homework. That's all our homework, guys. Here, and I'll show you everything we have left to finish for our Calculus 1 class before we proceed to Calculus 2. So here we have, first of all, what's our grade? Our grade is a 94.09. There it is. There you are, buddy. Cool. So, where's our homework? 100 out of 100, the final assignment of the class. And the only thing we have left, you guys want to know what it is? The only thing we have left is the quiz and the final exam. And that's it. That's everything we have left. Woo! Let's go. Well, guys, the next live streams for this class will only be preparing for the quiz and the final exam, and then we're all done. Well, everyone, thank you for sticking with me in this live stream. It was a lot of fun. It was hard work, but it was a lot of fun. And thank you all for being here in this almost 3 hour and a half, probably the longest one I've ever done. Well, I'll see y'all later. And